So we are looking at the mole ratio here. From here, so for every 1 mole of C3H4, I have 2 moles of water. This is the only time you're ever using a number or may use a number other than 1 in front of mole, okay? Whenever you're getting the mole ratio. All right, so if we were to stop here, these moles would cancel, and now I'd be left with moles of B, okay? But again, I'm not done. So lastly, what I'm going to do is I'm going to convert this to the mass of water. So for every 1 mole of water, so we're converting from moles to mass, so I have to divide by moles, and I'm going to multiply by the mass of water, which is going to be, again, from that periodic table that I gave you the other week. We take 2 times the mass of hydrogen, which is 1.006 on that periodic table, plus the mass of oxygen, which is 15.999 grams per mole on that periodic table. So this is grams per mole. Moles on the bottom. And that's water. So notice I have to keep putting my unit, and I have to put my label. There's no skipping around about that. Make sure that you're showing all of that. Chemists are very detailed, as you know. So now whenever I go to calculate, I'm going to cancel my grams of my fuel. I'm going to cancel my moles of fuel. I'm going to cancel the moles of water, and I'm left with the mass of water, which is going to be grams of H2O. And I'm going to plug all of this into the calculator, and I get 140.285 grams of water. And let's just see if that makes any sense, if I get my sig figs right first. So here I have 3 significant figures, and so that means I can only have 3 here, which is going to include the 0. The 2 does not round that up, but I need to include my decimal point. That makes that 0 significant. Okay, so let's see if this makes sense. I would take 156 divided by 40. Okay, so that's going to give me about 123. Okay, then I am going to multiply that by 2, so 6. Then 6 times almost 20, and see if that comes out to about 140. So again, what we do, you can do this 2 different ways. You can zip along 156 times 1 times 2 times 18, hit equals, and then divide by your 40, divide by 1. This could be other things. It's not always going to be a 1. Or you can just kind of jump back and forth. You can say 156 divided by 40 times 2. If this were a number divided by 3 or 7 or whatever this might be as far as your ratio, then multiply by this number, your 18. Okay, just think of this. This is on top, these are on the bottom. Anytime you enter the numbers on the bottom, you're hitting the dividing side. So we could go back through and we could say, well, there might be problems that say, well, you're going to have the same equation, and what if we need you to make X number of grams of water, okay, or X number of grams of carbon dioxide. That's what we expect from this reaction, or you're just trying to check how efficient it is. Okay, so if that's the case, you can use this as A, or this as A, and this as B. It doesn't have to be a reactant to a product. You can work backwards as well. So let's go ahead and do that. Okay, so in order to do that,